An introduction to statistics. Statistics is really a method of finding order in disorder. So the slide that you see in front of you is a series of ones and zeros with no seeming pattern, but there is some sort of pattern to it, and this would be equivalent to some sort of computer language, which could be something like the word order. In this video, we're going to look at the research process and data types, and nothing else. The research process. One way to organize or make a pattern of the research process, and you could have all kinds of quibbles about it, is the research process wheel. And we start off always with some sort of an idea. And these things kind of work together. So the idea and the lit review work together, because when you have an idea about research, you're going to read a little bit in the literature what research has been done, and as you read more about research you get more ideas, and these things kind of work together. Once you kind of settle on idea and you develop the idea and it becomes much more solid or well defined, then you can start working on design, writing a proposal, and then waiting for approvals. And then, so these are another kind of general section that kind of work together. So as you design, you propose, you go back and redesign, rewrite, wait some more, get some feedback. And so these two elements work together as well. And then finally, you're ready to collect data. Once you collect data, you analyze the data, and that's the second phase. So that's the most active phase of doing something actually, rather than writing and thinking. And then finally, again, we have a writing phase, and this takes a lot of time usually. You publish, you present your results in various forums, and then you can sit back, and really that's the shortest phase of all. So that's a kind of a quick look at the research process. In this course, stat1013, we're going to focus on really these two. Not collecting data as much, but the data analysis piece. The role of the statistician within the research process. Statisticians contribute to study design. We analyze data, and those are major pieces of the roles of the statistician. And the design, the better the design, the easier the data analysis is. In order to be able to design a valid study, it's crucial to be comfortable with data analysis. That's just no ifs, ands about it. Data analysis involves many elements. A process through which the researcher collects evidence that helps answer the research question. And that's the key. We want to answer the research question. And data analysis is what helps us do that. And this gives you a picture of data analysis. Data preparation, exploration, practical significance, written report. So these three, stat1013, we're going to look at, focus on these two actually. The written report less so. And then confidence intervals we're going to do a little bit in stat1013. The rest we're going to leave for stat2001. But I need you to learn this whole chart by heart, so please spend time to do that. Goals: we answer the research question, provide supporting evidence. So we're going to be the ones who are going to be clarifying what evidence you have and how you can answer the research question. We're going to build visual numerical representations, which are called models of the population which we're studying. Data is the heart of quantitative inquiry. Unit of analysis, you need to know what that is, what variables are, and about data collection. So the unit of analysis is the who or the what that we are collecting data from. So again, learn this by heart. because many students get confused by what is the unit of analysis. And if you're not sure of what the unit of analysis is, you don't really understand what research you're doing, because you don't understand who it is or what it is that you are studying. Variables are the characteristics for each participant. So for each person, for each carrot, for each light bulb, or whatever it is that you're studying. And so it's the characteristics that we're interested in. And a data collection, well, we're either going to be observing, doing a survey, or an interview of some sort. So observation means you are going to be taking a look. And here we're going to be talking or writing. What's the difference between the data needed to answer a research question on the left versus the right? So this is the left and this is the right. How did students over the last 5 years do in Math 11-12? Question mark. We got question marks here. Here, what we're interested in is the mean. Remember, that's the average. It's another way of saying average. Mark. 70% of students would have passed. So passed is a yes, no. This is a measure. So how are these different? Well, these are the key words here. This is a measure, and this is a yes, no. So this is, you're going to have all kinds of values possible from 0 to 100 theoretically. And here we have 70% of the students would have passed. That's yes. And 30% fail. That's no. So think about how those are different for a minute. On the left, we have a column of the mark. So that's a measure. And that's pass status, yes versus no. And you can see how this is the data set, how it's coded. And this is how the yes no is coded on the computer. Pass, passing mark, yes, no. So these are the yeses. These are the no's, these are the yeses. And this is the average mark, the standard deviation, which you learned how to calculate in Math 11-12. So these are different. I hope that you can see that. And these fundamental differences between different data types that drive the kind of data analysis that we're going to be doing with them. So we have categorical data and we have measurement data. So a mark out of 100 is a measurement. Whether the person passed or not, no or yes, is a categorical data. These are fundamental to the way we're going to approach data analysis. Categorical data can be nominal, so it's like which political party do you vote for, or ordinal, satisfaction with life. Strongly agree, agree, not sure, disagree. All those kinds of questions are Likert scales, and we classify by order. So that's our ordinal data. Discrete data and continuous data are subtypes of measurement variables. And discrete data, which most things are, things like age. So you're either 7 or 14 or 17 or 34 or 51. Continuous data is something that's measured in a much more precise level. Just in a bit of an aside, precision and accuracy are two terms that you should really think about. And those are often confused. So I got this picture from shmula.com. Nevertheless, if you having trouble take a minute to think about this. So you can pause the video right now and think about this picture and what accuracy and precision and how they're different. And if you're having trouble with that, think of your city. If I say you live in Toronto, that can be very precise, very accurate, but not precise. Keys to success in this course: learn the terminology, do the in-class exercises in class, write answers down. Can't stress enough that that's important. Make mistakes in class so that I can help you fix that. Practice with SPSS as much as you can. Read the given material and ask questions about whatever it is that you don't understand.